Turbines. Prime movers or turbines or energy conversion devices which is used convert energy from natural source into mechanical work. They are classified as thermal prime movers, steam turbine, internal combustion engine, gas turbine, hydraulic prime movers or hydraulic turbines. Turbines. Classification of hydraulic turbines. According to the type of energy at inlet of the turbine, impulsive turbine, reaction turbine. According to the direction of flow of water, tangential flow turbine, radial flow turbine, axial flow turbine. According to the head at the inlet of the turbine, high head turbine, medium head turbine, low head turbine. Turbines. Impulse turbine. Hydraulic prime mover is a device by which the potential and kinetic energy of water may be converted into mechanical work. It requires a continuous supply of water, so there should be a storage of water in a dam. The dam will maintain the supply of water in dry seasons too. Water is taken from higher level by means of penstock pipes to the prime movers. Turbines. Impulse turbine. If at the inlet of the turbine energy available is only kinetic energy, the turbine is known as impulse turbine. In impulse turbine, all the potential energy of water is converted into kinetic energy in the nozzle before striking the turbine wheel buckets. It requires high head and low discharge at the inlet. The water as it flows over the turbine blades will be at atmospheric pressure. Impulse turbine may be radial flow or axial flow or tangential flow. Turbines. Impulse turbine. Pelton wheel turbine construction. It is a tangential flow impulse turbine. This page also shows the figure of Pelton wheel. Turbines. Impulse turbine. Parts of the Pelton wheel: nozzle and spear, Pelton wheel with buckets, casing. Turbines. Impulse turbine. Working. Water at high pressure from the penstock pipe enters the nozzle provided with a spear. Pressure energy of water is converted into velocity energy as it flows through the nozzles. By rotating the handwheel, the spear is moved to control the quantity of water flowing out of the nozzle. When the spear is pushed forward into the nozzle, the amount of water striking the buckets is reduced. The jet of water at high velocity from the nozzle strikes the buckets at the center of the cup. The impulsive force of the jet striking on the buckets causes the rotation of the wheel in the direction of the striking jet. Thus, the pressure energy of the water is converted into mechanical energy. Turbines. Reaction turbine. If at the inlet of the turbine the water possesses both kinetic energy as well as potential energy, the turbine is known as reaction turbine. It requires low medium head with high rate of flow. All the pressure energy is not completely converted into kinetic energy as in the case of the impulse turbine. First, water enters the guide blades which guide the water to enter the moving blades. In the moving blades, part of the pressure energy is converted into kinetic energy which causes rotation of the runner. Water leaving the moving blades is at a low pressure. Thus, there is a pressure difference between the entrance and the exit of the moving blades. Turbines. Reaction turbine. Working of Kaplan turbine. Water at high pressure enters the spiral casing through the inlet and flows over the guide blades. The water from the guide blades strikes the runner blades axially. Thus, the kinetic energy is imparted by water to the runner blades, causing the rotation of the runner. The runner has only 4 or 6 blades. Water discharges at the center of the runner in the axial direction into the draft tube. The draft tube is of L shape with its discharging end immersed into the tail race. Turbines, reaction turbine, Kaplan turbine. It is a low head reaction turbine. Water flows axially. Kaplan 1916. Parts are spiral casing, guide wheel, guide blades, runner blades, draft tube. The diagram of Kaplan turbine is shown.